Why boosting is supervised? The first one is training process. Boosting focuses on minimizing the errors of weak learners by iteratively improving their predictions. This process requires a known target variable to measure errors. Loss function. Boosting algorithms optimize a loss function which compares the model's predictions to the true labels. And the third one is output goals. Boosting aims to predict specific outcomes which can only be achieved with labeled data. Does boosting ever work unsupervised? And the answer is yes. Cluster boosting. Boosting can enhance clustering by focusing on data points that are hard to group, though this is not a direct implementation of standard boosting. The second one is semi-supervised learning. Boosting can work in semi-supervised scenarios where some data points are labeled and others are not. The labels the data guides the training process. And the third one is anomaly detection. While often considered unsupervised, anomaly detection tasks may use boosting to classify normal and anomalous data when some labeled anomalies are available. What are the similar topics? Bagging and stacking. Bagging reduces variance, whereas boosting reduces both bias and variance. Stacking. In boosting, the models are trained sequentially with each model focusing on the errors of the previous one, while stacking involves training the models in parallel and combining their predictions afterward. What are the pros and cons? Pros: improved accuracy works well with weak learners. Flexibility handles bias and variance, handles imbalanced data, handles complex relationships. Cons: sensitive to noisy data, computationally expensive, requires careful tuning, memory intensive, poor performance with weak data. If you have any question, then feel free to ask us. We will try to give you the correct answer.